Okay, so we're going to try to process the data that you just got this week when working with analyzing an antacid. And I'm going to use some data from a few years ago that a student of mine got. So she used the antacid equate, and as soon as she got her 3 tablets into her 3 Erlenmeyers, she wrote down the cost of the antacid, which was $2.28 per 150 tablets. She also wrote down the concentration of the NaOH that she had found from last week. The concentration of the HCl, this was the one that was available a few years ago. You obviously are going to write down your concentration of NaOH and your concentration of standardized HCl that will be on the bottles on your desks. So to begin with, the pennies per tablet, that's going to be important in some of our calculations. So all we're going to do is convert that dollar amount to pennies and divide it by 150 tablets. Again, this is going to be different for yours than it was for her. This is just an example. And it turned out when she did the math that each penny cost 1.52 cents. Now this was data she wrote down here on the back titration. This was data she wrote down during her experiment. She masked the tablets. I'm only doing 2 of them. She masked the tablets and added the exact same amount of the standardized HCl to both Erlenmeyers. Remember, she labeled the Erlenmeyers so she knew which was which. She next had to find the moles of HCl, and the moles of HCl were found by using the concentration of HCl and the volume of HCl added in liters, so 0.02500 liters. Liters cancel, and this left us with her with 0.03063. Now, because she used the exact same solution, exact same standardized HCl, and the exact same number of liters of HCl each time, obviously the moles were the same each time. Now, this is her total moles of HCl. Once she added this HCl to her tablet and let it react for a while, crushed up the tablet, heated it, boiled off the carbon dioxide, let it cool a little bit, added her indicator, she titrated. Okay, so this is actually the second part. This is the official back titration part. And what she did was go from 0.00 milliliters to a perfect endpoint both times. And you saw in lab what the perfect endpoint was. We weren't using phenolphthalein, so it wasn't pale pink. But hopefully you got a perfect endpoint both times, all 3 times as well. So when she did these titrations, she found that the volume of NaOH she had used was 20.50 for this first one and 20.20 for the second one. Now she needed to find the moles of NaOH, and that was again just the concentration of NaOH she used times the volume in liters. So for this first one, 0.02050, which gave her the number of moles of 0.02091. This was not, the second trial was not going to have the same number of moles because she had a different volume. So she had to do this determination twice. and that was the number of moles she found. Now this is her total moles of NaOH, which is 1-to-1 with the unreacted HCl. So this moles HCl remaining in flask, or yours may say unreacted moles of HCl. 1-to-1 molar ratio. So we're going to write down the same number right here for moles of HCl unreacted as moles of NaOH used. Okay, so far so good. So our next thing, we're going to need all of the data, so I won't slide it all the way down. Moles of HCl neutralized per 1 tablet. Well, we have the total, we have the unreacted, so total, unreacted, and we're going to subtract those two to find the moles neutralized. So that would be 0.00972 for this one, 0.01003 for the second trial. So now we know our moles neutralized per tablet. That was the difference between these two arrowed things, the total and the leftover or unreacted. Gave us the reacted. Now we want to figure it out in terms of grams of tablet. We took the number we just found, moles HCl, neutralized per tablet, and then we multiplied it by 1 tablet over the number of grams, 1.1884 grams. Our tablets cancel, and that gave us moles of HCl neutralized per gram. And when she did this, she found that she had, for the first trial, 0.00812 moles per gram, and for the second trial, 0.00818 moles per gram. So finally, she sought this last thing, which is the cost effectiveness, which is the moles neutralized per penny. So again, she started with this moles neutralized per tablet, moles HCl neutralized per tablet, and then she used this data from way up here, 1.52 cents per tablet. So again, using the inverse, 1 tablet per 1.52 cents. The tablets again canceled, leaving moles per penny. Just like we want. And when she actually did this, she found her cost effectiveness for the first sample to be 0.00639 moles per penny, and for the second trial, 0.00646 moles per penny. And actually, I dropped a significant figure here. Now, how come trial 1 was 3 significant figures, trial 2 was 4? Well, look at the moles neutralized per tablet. Remember, this was a subtraction, so we had to keep the number of decimal places that the least were. So we ended up with 0.0, write it down here, 0.03063 minus 0.02091. And when she did this, she found it was 0.00972. There were only 3 significant figures left to deal with for her multiplications and divisions after that. On the other hand, trial 2 was 0.03063 minus 0.02060, which left her with 4 significant figures with which to work afterwards. So that's how you do the calculations for antacids.